This is the movie for pages 97 to 104, numbers 1 through 9. Number 1 says, what is the x-coordinate of the point of inflection of the graph equals y, of the graph of y equals 1/10 x to the 5th plus 1/2 x to the 4th minus 3 over 10. For a point of inflection, we need to find the second derivative. So y prime would be 5/10. Bring down the 5, x to the 4th plus 4/2 x cubed, and 3/10 would go away. Um, y prime, however, simplifies to 1/2 x to the 4th plus 2x cubed. Y double prime is 4 over 2x to the 3rd plus 6x squared, otherwise known as 2x cubed plus 6x squared. You would set this thing equal to 0 and solve for x, so you'd factor out 2x squared and be left with x plus 3. And so x could be 0 or x could be -3, which are both answers, but we can't have two answers. Important, you must make a number line here and analyze. So I have my f double prime number line. If I look at -3 and 0 and consider the factored form of my second derivative, make a sign chart, we'll see what happens here. So if I plug in a number to the left of -3, say -4, 2 times -4 quantity squared is always positive, and -4 plus 3 is negative, so a positive times a negative is a negative. Between -3 and 0, I'll plug in -1. 2x squared is always positive, and -1 plus 3 is positive, so now we have a positive times a positive being a positive. And past 0, I have a positive. 2x squared is always positive, and say 1 plus 3 is positive, so positive. So the graph of f is concave down, because this is the second derivative working with, on the interval -infinity to 3, and then concave up everywhere else, so -3 is the only inflection point, choice B. Number 2 says the graph of the piecewise linear function is shown. What is the value of the integral from -3 to 5? This is just the net signed area. So you could do this a few ways. You could break this up into triangles and rectangles. And actually, I think I'm just going to blow this up a little bit. So we can kind of do a better job of this here. That's better. Whoopsie. Okay, so let's see. I'll break this up. Here's a triangle, a square, a triangle, and another triangle. So these guys down here are going to be negatives because we're below the x-axis. So we have two times 2, which is 4, divided by 2 is 2, which is -2. This is a 2 by 2 square, so that's 4, but negative. This guy is a 1 by 2 triangle, so that's going to give us a -1 area. And then here we have a 3 by 4 triangle. 12 divided by 2 is 6. So -2 plus -4 plus -1 plus +6, I believe gives us -1, which, I'm sorry, the page number got etched over the choice. That would be choice E, -1. Okay, so number 3, the integral from 2 to 3 of 1 over x cubed dx is equal to, so this is the integral from 2 to 3 of x to the -2nd. We need to find an antiderivative by using the reverse power rule. So this would be add 1 to the power, so it becomes x to the -1 over -1 from 2 to 3. And this equals 3 to the -1 over -1 minus 2 to the -1 over -1. Actually, you know what? Before I do that, I'm actually just going to simplify this expression a little bit. Isn't this really just -1 over x? Because I have a positive divided by a negative, which is a negative, and I have x to the -1st, which goes downstairs as a positive 1 power. This is just going to make this a little easier. So here I have, if I do that first, I will have negative. Oh, you know what? I'm sorry. I wrote the problem wrong, didn't I? I'm looking at the answer choices going, man, those look a little too easy or a little too complicated for this problem. So, sorry. The original question was the integral from 2 to 3 of 1 over x cubed dx, and I wrote 1 over x squared for some reason. Sorry. Anyway, the procedure still holds. So the integral from 2 to 3 of x to the negative 3 dx, okay, is x to the negative second over negative 2 evaluated from 2 to 3, which I'll simplify to be negative 1 over 2x squared from 2 to 3, evaluated from 2 to 3, which we'll do like this: negative 1 over 2 times 3 squared minus negative 1 over 2 times 2 squared. So we have negative 1 over 3 squared is 9 times 2 is 18, plus 1 over 2 squared is 4 times 2 is 8. They have this as one fraction, so we need to figure out what this would be as one fraction. Well, if I multiply, my least common denominator is 30. Least common denominator here would be actually a multiple of 9, 72. So least common denominator is 72. Multiply 18 by 4 and 4, and 8 by 9 over 9, and we'll get that. So you have negative 4 plus 9 over 72. This becomes 5 over 72, which is choice D. And by the way, if you think about the signs here, 1 over x cubed looks like this. So it's above the x-axis. So our integral from 2 to 3 should be a positive 5 over 72 and not a negative 5 over 72, in case anybody was wondering. All right, number 4 says f is continuous on the closed interval a to b, but not differentiable for some c value between a and b. So it says, which of the following could be true? X equals c is a vertical asymptote of the graph. Well, if x equals c was a vertical asymptote, the graph looks something like this at c. Well, that would not be a continuous function. So, because remember, a graph needs to be continuous, so that's not true. B says the limit as x approaches c of f of x is not equal to f of c. Well, if my limit exists, let's say, but is not equal to the actual value at c, we get a discontinuity. We already said the function was continuous. So this is a matter of looking through the choices and seeing which one matches up, and seeing which answer choice is going to be consistent with the continuity part. Letter C says the graph has a cusp at x equals c. Well, if it had a cusp at x equals c, it would be continuous, but it would not be differentiable. Aha, that seems to be the answer. F of c is undefined. Well, if f of c is undefined, that means there's no number. So when I look at c, whatever that graph's doing before and after it gets to c, at c there is no number. There is a hole of some sort at c, which would make it not continuous. And none of the above is not true because we have c as the answer. So choice 4 was C. Number 5, the integral from pi over 2 to x of cosine of t dt. I think we almost did this problem today when I was explaining one of the other questions. We need the antiderivative cosine, which is sine of t. And we're going to evaluate that from pi over 2 to x. So this becomes sine of x minus sine of pi over 2. Sine of pi over 2 on the unit circle, pi over 2 is 90 degrees. Our unit circle point is 0, 1. It goes cosine sine. So the sine of 90 degrees is 1. So we get sine of x minus 1, which is choice D. Number 6, if x cubed plus 2x squared y minus 4y equals 7, then when x equals 1, dy dx is. We had a very similar type problem on the homework last night. We need to take the derivative with respect to x on both sides. We have the derivative of x cubed, which is 3x squared, plus 2x squared y. I'm going to come over here and look at this in terms of the product rule. So I have 2x squared y. We'll split this up. The derivative of 2x squared is 4x. The derivative of y is dy over dx. And we'll product these guys up. So we get 2x squared dy over dx plus 4xy minus 4 dy over dx equals the derivative of 7 is 0. I want to move all my, let's move this over so it doesn't look like it's part of the problem. I want to move my non-dy, my dy dx's, or have my dy dx's on one side. So it looks like it'll be easier to subtract 3x squared and 4xy from both sides. So now we get 2x squared dy over dx, minus 4 dy over dx equals negative 3x squared minus 4xy. And so we can factor out our dy dx. And divide. The dy over dx is negative 3x squared minus 4xy over 2x squared minus 4. So here's my dy over dx. They want it when x is 1. So when x is 1, I hope you see we're going to run into a little problem here. When I filled in the 1, there's a y in the derivative. I need to find out what the y is. So it's kind of the scenario. It's when x is 1, y is something. So we have to go back and figure that out. We're going to go back to the original. So when x is 1, y is something. Well, let's see. I have 1 cubed, which is 1, plus 2 times 1 squared y, minus 4 times y equals 7. So let's see. I got 1 cubed is 1, plus 2 times 1 squared is 2y, minus 4y equals 7. 1 minus 2y is 7. Subtract the 1 over. Negative 2y is 6. And so divide by 2, and y is negative 3. So if y is negative 3, I can come down here and get a value. So we have negative 3 times 1 squared is negative 3. Negative 4 times 1 times negative 3 is positive 12 over 2 minus 4, which is negative 2. And now we have negative 3 plus 12 is 9 over negative 2, which is negative 9 over 2, which should be the answer, choice A. So a lot of work, but nothing you can't handle there. Number 7, we want the integral from 1 to e squared of x cubed plus 1 over x dx. Might be tempted to use a u substitution. You might say, well, u is x cubed plus 1. That's the bigger power, and du dx would be 3x squared. But the problem is that I have an x here, not an x squared. So u substitution would not be an acceptable method for this problem. But what would be is to split up the fraction by sharing the love and use the power rule. So we have the integral from 1 to e squared, x cubed divided by x, plus 1 over x dx. X cubed over x is x squared, plus 1 over x dx. And, you might see there's e's involved. That could give you a hint that you're going to have a 1 over x because you're going to have an ln at some point. But anyway, that's probably not the best hint. All right, anyway, you're going to take the antiderivative of both terms now. So the antiderivative of x squared is x cubed over 3. Antiderivative of 1 over x is natural log of absolute value of x. Evaluate this whole thing from 1 to e squared. So now we have e squared cubed over 3 plus the natural log of absolute value of e squared. I'm not even put the absolute value bars in because e squared is already positive. Minus 1 cubed over 3 plus ln of absolute value of 1. E squared cubed is e to the 6th over 3. Ln of e squared means what power of e do I need to get e squared? Well, the power is 2 minus 1 cubed over 3 is 1 over 3. I'll distribute the negative sign, but I won't really have to, only because ln of 1 is a big fat 0. So now we have e to the 6th over 3 plus 2 minus a third. They have made the answers separated, so I don't have to actually make, well, I'll have to put the numbers together. So I have e to the 6 over 3. This is, if I make common denominators with the numbers, if I have 2 over 1, I'll multiply by 3 over 3. I'll have 6 over 3 minus 1 over 3, which is 5 over 3. So altogether, we'll have e to the 6 over 3 plus 5 over 3. E to the 6 over 3 plus 5 over 3. Choice B, they just wrote it as 1/3. And one more, I believe this one's tricky. It says let f and g be differentiable functions with the following properties. F of x is less than 0 for all x, and g of 5 is 2. It says h of x is f over g, and h prime is f prime over g. Well, I want to think about something for a minute. H of x is a quotient, so h prime should follow the quotient rule. So if we do that, okay, h is f over g. Derivative of f is f prime. The derivative of g is g prime. And so h prime of x is low d high. So I should have actually put that in here. High, low, high prime, low prime. Low d high is g of x times d high, which is the derivative of f, minus high d low, which is f of x times g prime of x, all over low squared, which is g of x squared. Now they told us, if you can see, that h prime was really just f prime over g. Well, if you see right here, I have my f prime in the quotient rule here. I have my f prime and I have a g squared here. I kind of want to produce out of this f prime over g. So here's what we're going to do. We're going to take this fraction and we're going to share the love and split this up. And something interesting happens. I told you this was a little bit of a hard problem. So h prime of x is g of x, f prime of x, over g of x rather, squared, minus f of x, g prime of x, over g of x squared. So now, if I think about what happens here, on this fraction, one of the g's cancels. And I get h prime of x to be f prime of x times g of x minus this other term. But if this is the actual h prime, and they also told me that h prime was just the first term, that means, because we know h prime is just this first term, that means this second term, this blob here, since h prime of x is just the first term, that means the second term that we get from the quotient rule, that term has to be 0. Because otherwise, h prime of x would have to be something more than just f prime over g. So h prime is not what I meant to say. What I meant to say was this second term now we know, this f of x, g prime of x, over g of x squared term has to equal 0. Now, if I have a fraction, the bottom of if I want to set a fraction equal to 0, the denominator doesn't matter, or multiply both sides by g of x squared, and the g of x squared term will vanish. And now we know that f of x times g prime of x is actually equal to 0. So, going back up to the conditions, they were nice enough to tell us that f of x is less than 0. So this number here, this f of x, is always less than 0. So when you think of, if you have two numbers multiplied to 0, okay, that means one of these things, either f or g prime, had to be 0. However, since f of x was always negative, this forces g prime of x to equal 0. So now g prime of x from here is forced to be 0. Well, if g prime of x was 0, to get back to g, what things have a derivative of 0? Constants do. So g of x had to be a constant. Since g of x was a constant, we have to look back to the second condition. It said g of 5 was 2. So we knew g of 5 was 2, but g of x is just a constant. So if g of 5 was 2, that forces everything else up to be 2, because g of x is the same number no matter what the x value is, whether it be 5, whether it be 9, whether it be e squared, whether it be -3. So g of x is actually 2, which is, this is a tough question. The answer is E. Tough question for sure. That's one that if I were taking the exam and I were in your shoes, I probably would skip or guess on or come back to later. Whoopsie, we're not done. I thought we were done for some reason. We actually have another question to go here. Number 9. Sorry about that. The production rate of cola in thousands of gallons per hour at the production plant on July 1st is shown in the graph. Of the following, which best approximates the total number of thousands of gallons of cola that were produced that day? Another units question. I gave you the production in gallons per hour. So this graph is gallons per hour. This is the derivative, and your x-axis is hours, and I want to produce the total number of gallons, or number of thousands of gallons. So I want the number of gallons here. So I want to integrate. Anytime you have a rate and you want to get the total amount of whatever you're doing, you integrate, say, from 0 to 24 of the rate function. I'll just call r of t dt. And it says, which best approximates that? On a graph, this is the area underneath the curve. So I need to do some sort of approximation, a reasonable approximation to get the area. So if you think here, certainly I have these boxes, which if this is 24 times 100, this is 2400. So clearly this answer is too small. Now I certainly have these boxes. Very easy boxes to see here. Each box is worth 6 times 100. So this is 600. So this is 1200. So we'd have 36. And now if we kind of estimate here, this is kind of an estimation problem. If you see these guys, probably a little more than half the box. So each box was 6. I'm going to call these about 400 a piece, just to approximate. And then I still also have these chunks here, which I'm going to estimate them to be a little less than half of the box. So I'll call it 200, 200. And if I add those up, 24 and 12 is 36. 36 and 4 is 40. 44, 46, 48. I get a pretty good approximation. 4,800. There's your answer. And now the video's over.